Hi guys, here we are with lesson 3.2 on synthetic division and the remainder theorem. So first thing we're going to do is we're going to recall long division from way back in probably grade 4, and we'll talk about what some of the terms were when you divide things. So I'm going to take 48,567 and I'm going to divide by 12 using the long division method. So the way that we did long division back in grade 4 was we took a look at what's called our divisor, and we tried to see if it could go into this first number. So can 12 go into 4? No, it can't. So that we extend this to be this number. 48, can 12 go into that? Yes, 12 can go into 48 4 times. Then what we would do is go 4 times 12 is 48. We would draw a line and we would subtract these two numbers. You pull down the next number and you try again. Can 12 go into 5? No. What about 56? It could go into 56 4 times. Now, since it couldn't go into 5, I put a 0, but it can go into 56 4 times. 4 times 12 is 48. Subtract, and you're left with 8. Pull down the 7. 12 goes into 87 7 times. 7 times 12 is 84, and we're left with a remainder of 3. So that's a quick reminder of how to do long division, but the most important part is what are these things that we're dividing and the answer that we're getting, what are all of these called? So the 12, the thing that we were trying to divide into the big number was the divisor. The big number is called the dividend. The remainder is what we get at the bottom here, and the answer is our quotient. All of that terminology is summarized on this slide here. Now, what if we did this with polynomials? So what I'd like you to do right now is put your pencils down and just watch the video. I don't even want you writing these notes in the long run. So just watch what I do. There's a method to my madness, and we'll talk about all of this after. So when I talk about polynomials, I'm talking about 5x cubed minus 13x squared plus 10x minus 9 being divided by something like x minus 2, another polynomial. How would we do something like this? Well, we would take a look at the 5x cubed. We would say, what do I need to multiply this first one, x by, to get 5x cubed? Well, that would be 5x squared. I would multiply both terms. I'd get 5x cubed minus 10x squared. I would subtract all of these. Negative 13 subtract negative 10. Those would actually turn into a plus for two negatives. And I'd start again. Pull down my 10. Think about what I can multiply x by to get negative 3x squared. Negative 3x would work. Negative 3x times negative 2 would be positive 6x. And I would subtract both of these terms. So this would become plus and this would become minus. Those cancel, and I get 4x. Pull down your last term. Repeat the process. Subtract both of these, and you get a remainder of negative 1. So what you should be looking at on your screen right now is quite a mess. This looks extremely overwhelming, and there's a lot going on. There's lots of math skills that applied here. And the reason why I had you put your pencil down is because there's a much easier way. So this is called long division, and what I'm going to teach you is something called synthetic division. So synthetic division is a simpler way to do exactly what I just did, but without so much work with adding and subtracting polynomials. There's not even going to be an x anywhere to be seen. So this is a really slick method. The thing you have to remember with synthetic division is you must have a number in every position. So that means if you have a polynomial like x cubed plus x squared plus 5, you are missing an x term. So you'd have to put a place of 0 in there. I'll show you an example of this later. I'm going to do the exact same question, which was 5x cubed minus 13x squared plus 10x minus 9 divided by x minus 2. I'm going to do this with synthetic division. So the first thing is terminology. That x minus 2 is called a factor, potentially. And what we need to do is we need to set it equal to 0 and get what's called our root. So our root for this one, if I move the 2 over, is x equals 2. Ultimately, what's happened here is in the brackets, it was a minus 2, and our root is a plus 2. Just change the sign. That's all you have to do. Now you're going to write that 2, and you're going to write a box like this. Now you're going to put the coefficients for all of your terms in descending order in this box. So this is where we have to make sure we have x cubed, x squared, x constant. If one of those x's was missing, we'd have to assume it was a 0 in that place. So I'm going to write the coefficients. My x cubed coefficient was 5. Leave a little bit of space, and then do your next one, and your next one, and your last one. Now, the first step for synthetic division is to take your first coefficient, pull it down, and write it. That's it. Now, what you're doing to get the next number in this box is you're going 5 times 2 is 10. Now, what's going to happen here is this is always addition. This is why I like this method. We don't have to subtract like the other one, which was a little complex. Negative 13 plus 10 is negative 3. Repeat the process. Negative 3 times 2 is negative 6. Add 10 plus negative 6 to get 4. Repeat the process. 4 times 2 is 8. Add it to negative 9, and you get negative 1. I draw a little line here because this is the exact same question, remember. The negative 1 is the remainder, and the numbers that you got when you were doing your synthetic division down here are exactly the same coefficients from the previous slide. So this says that if you divide 5x cubed minus 13x squared plus 10x minus 9 by x minus 2, you are going to get 5x squared minus 3x plus 4 with a remainder of 1. So how could this look? 5x cubed minus 13x squared plus 10x minus 9 was divided by x minus 2, and we got 5x squared minus 3x plus 4. But we did have a remainder, so all you would say is you've got a remainder of negative 1. So pause the video now and take a moment to write down the steps that I just walked you through, and then we'll do quite a few more examples. All right, what does this mean? So 20-1 or 20-2 or 30-2, we take a look at quadratics a lot. So we factored quadratics and we ended up with two brackets like this x plus 6, x plus 1. When we factored quadratics, what were we looking for? We were looking for x-intercepts, aka roots, aka zeros. So these were the factors, and the x-intercepts, or the roots, or the zeros, all mean the same thing, were exactly the same numbers, but the signs have been switched. Okay? So this is telling you x-intercepts. So when we're trying to factor something that's of a bigger degree, so all we could do in grade 11 was x squared, degree 2. If we want bigger polynomials to be factored so that we can find the x-intercepts, we use synthetic division to do that. If we get a remainder of 0, then it factors by that number. So what does this look like on a graph? You've got your Cartesian plane, and I don't know exactly what 5x cubed minus 13 blah 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 looks like, but let's assume it looks something like this, some cubic function. What we know for sure when we tried to divide x minus 2 from it, we know for sure that the root of 2, so an x-intercept of 2, is not on the graph. How do we know that it's not on the graph? Well, we got a remainder. So the only thing that will tell us that an x-intercept is on the graph with this method is a remainder of 0. So we need to see that remainder of 0 to know that that's an x-intercept. So by seeing a remainder of -1 on the last question, we know that the root of 2 that we started with is not an x-intercept. Here's something called the remainder theorem. It's exactly what I just said. If there is a remainder, then that factor does not correspond to an x-intercept on the graph. If the remainder is 0, it does. So with our quadratic example, or pardon me, our cubic example that we had a function that looked like this. Again, I should write cubic here, but this is the same function we've been working with. And what we did is we tried to see if an x value of 2 would give us an x-intercept. What does that mean? If an x value of 2 gives us an x-intercept, remember x-intercepts have y values of 0. So if I sub in an x value of 2 and put this in my calculator, if I get any number except for 0, then that is not an x-intercept because it doesn't have a y value of 0. So we got a -1. So that really tells us that at an x value of 2, the y value is -1. We found a point on the graph, but it's certainly not an x-intercept like we were looking for because the y value is not 0. Let's try another question by synthetic division. First things first, get your terminology right. Whenever you do a question, I'd like you to say what this is. Is it a factor or is it a root? When it's in brackets with x, this is the factor. Okay, we usually start by giving you the factor, and then what you have to do is you have to translate it into what the root is. Remember, that's as simple as changing the sign to be -3. That's the number that goes out in front of your synthetic division, and the coefficients on the numbers go on the top row. Now you have to double check before you write them down that you have every term. So if we have x cubed, the next one needs to be x squared, x constant. If any of those are missing, you need to put a 0 in its place. I'm just going to write down the coefficients now, leaving space so I don't get confused. And I'm going to pull down the first number. Now we multiply. 2 times -3 is -6. And then we just add. 3 plus -6 is -3. Repeat. -3 times -3 is 9. Add it to -4 and you get 5. 5 times -3 is -15. Add it to 15 and you get a remainder of 0. This is happy days if we get a remainder of 0. We just found out that this is indeed a factor, and it is going to give you an x-intercept of 3 if you were to graph this in your calculator. So let's write out what we just found. We found that this function equal to 2x cubed plus 3x squared minus 4x plus 15 is actually x plus 3 times the answer that we just got. So how do we write this as an answer? Well, if we started with x cubed and we divided out our term, the next thing we're going to get is x squared. The -3 corresponds to an x. It's in the x column. And the last term of 5 will be a constant. So it can be the trinomial 2x squared minus 3x plus 5. So we've just done the first step in factoring this function. We could continue and we could see what multiplies to 10 and adds to -3 and keep going to factor it further. But what we know for sure, because the remainder is 0, that means that x equal to -3 is a root. And remember, we can use any of these terms to describe a root. A root is the same as a 0 and the same as an x-intercept. Try the next one. This is the example I've been alluding to where a term is missing. We jump from x to the 4 to x squared. The x cubed factor in there is 0. So I'm going to rewrite this 5x to the 4 plus 0x cubed minus 3x squared plus 2x minus 7. If you don't put a 0 in that place, this won't work. So we're dividing by the factor of x plus 2, which means the root is -2. -2, set up your synthetic division. This is where the 0 is very important. Pull your first term down and go through your process of multiplying, writing the answer here, and adding vertically. Multiply, add vertically, multiply, add vertically, multiply, add vertically. You can draw this line to separate your remainder from the rest of your polynomial. Since the remainder is not 0, x equal to -2 is not an x-intercept, but we can still write that our original polynomial when divided by x plus 2 will give you this new polynomial, 5x cubed minus 10x squared plus 17 minus 32, 17x, pardon me, times the x plus 2 that we tried to divide, but there was a remainder of 57. So this wouldn't work out nicely to give you a remainder of 0. Now the worksheet there is attached on the website, but we are going to move on. You can pause the video and try that worksheet and come back later if you wish. The rest of this continues to use the same synthetic division and the same remainder theorem that we looked at. The remainder theorem is going to be used in this one to see if you can divide x cubed minus 10x plus 6 by x minus 4. This is essentially a shortcut. You can absolutely do this by synthetic division and do the whole process, but with the remainder theorem, we can go ahead and we can say that if we replace x with the root, which in this case would be, remember to switch the sign here, positive 4, if we get a y value that ends up being 0, we have an x-intercept. So let's see, if I put a 4 in this equation up here, it would look like this. If I evaluate that and put it in my calculator, I get a number of 30. Since the remainder is 30 and not 0, that means that 4 is not going to be an x-intercept on the graph. This is actually the point 430 on the graph, but since there's a remainder, x equal to 4 is not a root. So if you were to take that example and do the whole synthetic division process, you would get a remainder of 30. This is, however, a much faster way to find it. Next question asks us to do synthetic division. So here's just another review. First thing I'm checking, I've got x to the 5, x to the 3. I have to put in a 0, x to the 4 in there. Then I've got x squared. I'm missing an x before my constant. So what I'm really trying to factor here, whoops, that should be a 0, not a 10. Is this huge polynomial here. Once the zeros are in place, I'm ready to set up my division. Say to yourself, is this the factor or the root? When it's with x, it's a factor. When you have x equals, switching the sign, it's a root. I'm going to put the root down here. I'm going to put my coefficients with my zeros as placeholders in the top row. I'm going to pull down my 4 and start the process of multiplying, writing it in the next spot, and adding vertically. You might start to get really fast at this when you start going and end up with a solution that looks like that. Very important that you write your solution. This is simply your work, but you have to write what this is all equal to. So if we started with 4x to the 5, your solution is always 1 less in the exponent. So this is going to be 4x to the 4 minus 4x cubed plus 1x plus, or pardon me, plus 1x squared plus 6x minus 6, just like that. The remainder of 0 means that one of your roots is the point -1, 0. That's an x-intercept because the remainder was 0. Now, when this function p of x is divided by the factor x minus 1, the remainder is 3. What is the value of k that's missing? So we're going to use the remainder theorem. We're going to sub the remainder in for x, and we know that the y value associated with it is going to, or pardon me, we're going to sub the root in for x, and the remainder will be the value p of x. So this part, the y value, is 3, and all the little x's are going to be 1. Remember to switch the sign. So this is what it's going to look like. I'm going to make all of my x's 1 in this equation. Remember to do it in brackets, because if they are negatives, it's very important to have brackets. And then I know that the remainder, so this side is going to be equal to the number 3. This is going to be 1 plus 4 minus 1 plus k. And now we can simply minus 4 from both sides and get k equal to -1. It's just a fluke that it ends up being -1 and the factor had -1 in it. It could have been any number. Now, in addition to the worksheet that was assigned, there are some textbook questions here as well. I would love to help you with any of this work that you're not quite getting on a video chat or an email. Just let me know.